Hi, and welcome to the video about finding volume with unit cubes. Our goals for this video are to determine the volume of a rectangular prism with fractional side lengths and solve real-world problems related to the volume of a rectangular prism with fractional side lengths. Before we get started, we are going to be working with fractions today, and I wanted to remind you how to multiply fractions. This one says the distance from Colton's house to his school is 5/6 miles. He rides his bike 9/10 of this distance. How far did Colton ride his bike? I want you to remember that the word of we've learned means to multiply. So we're taking 9/10 and we're multiplying it, okay, by the distance that he has to go, which is 5/6. Okay, now there's a couple, you could just multiply across the top, multiply across the bottom. One thing that you can also do when only multiplying fractions is you can look at your numbers that are diagonal from each other and cross simplify if possible, which means you're going to divide them by a common factor if there is one. 9 and 6 can both be divisible by 3. Are both divisible by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. So I can simplify that way. 5 and 10 are both divisible by 5. So I can simplify these by dividing both sides by 5. And these are going to make my numbers. It's kind of like I'm simplifying beforehand rather than at the end. So now I have 3/2 times 1/2. 3 times 1 is 3. 2 times 2 is 4. That means, how far did he ride his bike? 3/4 miles. Okay? So let's talk about first what volume is. The volume of an object is the amount of space it occupies and is measured in cubic units. Volume of a solid can be found by observing how many cubes, unit cubes, it takes to pack the object completely with no overlap and no gaps. Then multiplying that amount by the volume of one cube. So if we find out how many cubes it takes to fill this 3D figure, and we know the volume of one of them, we can multiply those numbers together. So in this example, I know that there are 6 cubes on top, and there are 2 levels, which means that it's packed with 12 unit cubes. Okay, so number of unit cubes, 12, times the volume of one cube. They're telling us it's just 1. Sometimes it could be 2, sometimes it could be 1/2. You'll just have to look at the problem. 12 times 1 is 12, so the volume of this solid is 12 units cubed. And the reason you see this 3 here for volume, remember area has a 2, volume is cubed because volume is your length of an object times the width times the height. So you're taking your 3 dimensions and multiplying them by one another, which gives you 3 dimensions, which means that it's to the 3rd power. So how do we do this when it comes to fractions? Okay, for this rectangular prism, you're going to determine the length of the unit cube that you would use to pack the prism. Determine the number of unit cubes that you would need to fill the prism, and then find the volume of that prism. Because all of these are not whole numbers, I'm going to fill this with half cubic inches cubes, which means I have to figure out how many 1/2 does it take to fill 12 1/2. Okay, So in order to figure this out, I'm going to take each dimension and I'm going to divide it by 1/2 because I want to know how many halves fit inside 12.5. So I'm going to make this improper. That would be 25/2, and I'm going to multiply by the reciprocal when dividing with fractions. So remember at the beginning we talked about how when you're multiplying fractions, diagonal numbers can simplify each other. These are both divisible by 2, so they change to 1s. So 25 times 1 is 25, 1 times 1 is 1. So 25 cubes fit within the length of this, okay? Now I'm going to figure out how far back it goes. So I'm going to come over here and do 4.5 divided by 1/2 cubes. That's going to be 9/2 times 2/1. Again, my 2's cancel, and I'm left with 9/1, which means 9 cubes go back. And then now I'm going to find my height, 6.5 divided by 1/2. That changes to 13/2 times 2/1. My 2's cancel. And my answer is 13/1. So I know that 13 cubes can go up high. So now, in order to figure out how many cubes fill the prism, I could find how many go on the bottom, 25 times 9. And then I'm going to multiply that by 13 because it goes up 13 layers. So that's 45, 18 plus 4 is 22. So 225 is on the bottom layer, but I have 13 of those layers. So that's 15, that's 7, 6, placeholder, 5, 2, 2, ran out of room. So my total volume, when I do 25 times 9 times 13, I get 2,925, and that's inches cubed, if I'm filling it with 1/2 cubes. Okay, so let's try this one. A toolbox is shaped like a rectangular prism. The toolbox is completely filled with 1,680 plastic cubes. So that we're kind of working backwards. Here we found how many cubes it took. Okay, and actually this should say cubes, I'm sorry. Okay, and this time they're telling us that. They're telling us this is how many cubes. And each have an edge length of 1/2 inch. We're going to find the volume of the toolbox. Okay, so we're going to take our number of cubes and we're going to multiply it by the volume of 1 cube. Okay, and I want you to think about this. If I knew that the volume of a cube was 5, that means I would multiply this number, the number of cubes, by 5. I don't know my volume yet, but I do know that on this cube, I'm going to draw one real quick, every dimension is 1/2. So the length, the width, and the height is all 1/2. So in order to find the volume of that, I need to multiply my dimensions together. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 again is 8. So the volume of one of these cubes is 1/8 inches cubed. So I'm going to multiply my total cubes by the volume of 1 cube. Okay, so I'm going to put that over 1. So I'm doing 1680 times 1, 1 times 8, and now I need to simplify that. So I'm going to do some division. 8 goes into 16 twice, 8 goes into 8 once, and 8 goes into 0 0 times, and that stays as a 0 out. This means that my volume is 210 inches cubed. Okay, so for this one, a rectangular prism has a length of 5 1/4 m, width of 4 m, height of 12 m. How many unit cubes with edge lengths of 1/4 m will it take to fill the prism? What is the volume of the prism? So again, I have to do each dimension, divided by the size of a cube, the edge length, to figure out how many of these fit in here. So you could pause this video and figure that out. Okay, so this will change to 21/4 times 4/1. My 4's cancel, which means I get 21. This will turn to 4/1 because this changes to a fraction times reciprocal 4/1, which is 16. And this will change to 12/1 times 4/1, and that is 48. So in order to figure out how many cubes, I'm going to take 21 on the bottom times 16 times 48. And because of our time, I'm going to do this off to the side. That is going to be 16,128 cubes. Let me just double check my math. Yes. Now, to find the volume, remember, you're going to take the number of cubes and multiply it by the volume of 1 cube. Well, the volume of 1 cube is 1/4 times 1/4 times 1/4, because again, the edge lengths are 1/4, and that is 1/64. So I multiply across the top, multiply across the bottom, and I ran out of space, so I'm going to actually go to the next slide and finish this. So 16,128 times 1 is the same. 1 times 64 is just 64, so I'm dividing these. And that is going to give me 252, and it was m cubed. And that will be my volume. So before you stop today, make sure you feel like you can determine the volume of a prism with fractional side lengths, what we just did, and also solve real world problems related to the same. Thanks for watching. Have a great day.